So, good morning, everybody. We are officially, it was 9:32, so we're right on track. My name is Dr. Mila Marshall. I am the Clean Water I'm the Clean Water Advocate for the Illinois Sierra Club chapter, and thank you all so very much for joining us. We will have other people trickling in. I first want to say this venue, right? Shout out to Peggy Nodebart. Definitely thank them for allowing us to have this event here, and hopefully you'll have some time to check out the exhibits. It is a beautiful, beautiful museum. A little bit about the Clean Water team. We focus on statewide water issues, and we also have the lovely honor of organizing our water sentinels across the state. We are ramping up how we support our water sentinels that are doing water sampling and water monitoring. It is really important to know what is in our water. Our state agencies sometimes are under-resourced, and so we do fill in the gap. Lately, we want to make sure that our water sentinels are as supported as they can be, both in their skill set, with their resources, and their understanding of the various water issues that they face in their communities. Also, at the larger level, what's going on in the state. So while, I realize that some of you have varying levels of experience with water sampling and water monitoring. I hope that you will find all of the speakers both engaging, and you can take something back with you new, and not only for you, but how do you translate this to your team and other people in your network? Because that's another part of this. We have great presenters, and so you will be responsible for taking some of this information, the resources, and putting the rest of your team on. We will be doing this 2 other times, and so we will be doing this August 2nd in Springfield with the local Sierra Club group downstate at the Lincoln Memorial Garden and Nature Center, so beautiful, beautiful venue there. And then August 16th, we're in competition with the state fair. So, if you have people that don't want to travel to Springfield, send them in the opposite direction. But we'll be at the beautiful Nahant Marsh in their education center, and the Quad Cities group is the local group that's co-hosting there. We do have Jim Bland, who's going to start us off with macro invertebrates, Gloria Charlin, who is honestly the reason that we're all here. And I want to say thank you again for having invited the Illinois chapter to do this with you. And so she'll share a little bit more on cyanobacteria, toxins and testing. Then we will have the Chicago group, Jeff Sheldon and Connor, that will be talking about water testing in the Chicago River and giving you some opportunities to move through their protocol. Dr. John Ferry from the University of Illinois at Springfield will be talking about cyanobacteria in the southeast. I'll leave it at that. And then we will be free to go. And with that, welcome. Thank you.
What I wanted to do first is to introduce the sorts of things that we'll look to do for today. The guide that you see there, Aquatic Macroinvertebrates of Illinois, is something that I wrote in conjunction with the Riverwatch program. And it's intended to go along with the Riverwatch material. The second sort of thing is I wanted an opportunity for people to browse through important macroinvertebrate literature. What you see on the table are some books. At least one of those books costs $300. Your chances of being able to go through them, other than going to a library, are pretty slim. But I wanted you to see those, know what they're like, and there are, the Aquatic Entomology book, for instance, is just an absolute classic. It's a wonderful, wonderful book. So I wanted you to have an opportunity to go through those things. The last part of it is to do an ID exercise. And we have put the names of what you're going to be looking at on the vials, so you don't necessarily have to do an unknown for the purpose of it. One of the things about this work is that it originally started in the 1970s with a gentleman named William Hilsenhoff. And Dr. Hilsenhoff was from the University of Wisconsin, and he came up with a scheme for using macroinvertebrates to help grade water quality. And it's not just the macroinvertebrates themselves, but rather the sensitivity and the response of those organisms to different types of pollutants. So it's a dual sort of thing that he uses. Since then, there has been a substantial expansion of the character of this work. There's many people that have adopted it. There are new types of grading schemes for it, and there exists a national database that helps people to grade it as well. So, 3 things. Going to go through the macroinvertebrate guide. Going to browse through, give you a chance to browse through these books. And lastly, do an ID exercise. Now, normally, there's a scream that's associated with this. And normally, all of you would be waking up in a big, big way. Oh, very good. Now, why a scream? My niece was invited to our house to go canoeing. So she got over to the pier, then she got into the canoe, and then she saw a mayfly, screamed, bolt upright, jumped onto the pier, and we could not get her back and into the canoe. In the case of University of Illinois entomology group every year puts on an insect film festival. So they show the fly and other good things. We hope that you'll be a lot more comfortable dealing with macroinvertebrates at the end of our presentation. So why did I do it? I did it because the line drawings from Riverwatch were really quite bad, and good luck in being able to do identifications. So the photographic work and the narrative part of it were things that I did. Riverwatch was created in 1995, and it's been taken over by the Great Rivers Research and Education Group. Now, it trains citizen scientists to sample stream biology, and it creates a database of macroinvertebrate samples and metrics. So going back from 20 years, there is a database that Riverwatch has created from the different places in which citizen scientists have been able to do monitoring. And it's capable of tracking long-term trends. Is it the same as doing work for Illinois EPA or the other agencies? No, it is not. What's up is there are approximately 40 taxa that are associated with the Riverwatch program. If you were doing work for IEPA, you would have to be familiar with 1,400 taxa. All of those, in addition to what the name of the organism is, and for purposes of IDing it, all of those have a weight that is given in terms of their relationship, mainly with types of organic pollution from things like sewage treatment plants and through nutrient types of things. So it's not just the name of the organism, it's the name and its weight that winds up being important. Okay, benthic macroinvertebrate. Benthic is living in or near the stream bottom. Macro, it's large enough to see. Invertebrate, it lacks a backbone. What are you looking at in the book? You're going to be looking at aquatic worms, insects, mollusks, and crustaceans. They live in various habitats, includes riffles, leaf packs, snags, sediment, and stream banks. Impacted by pollution, habitat changes, and other natural and normal causes. Okay, as water quality indicators, they're abundant and they're easy to collect. That's one of the first things that Dr. Hilsenhoff recognized, that this is a much easier way to be able to do some simple assessments of stream reaches. They're relatively immobile. I shouldn't say that, but they're not like fish. So fish move around tremendously. The macroinvertebrates are more static and stay in place. They're critical parts of food webs and energy dynamics of streams. What you will see, I've given you a sheet that's got a list of the taxa that is associated with Riverwatch. So what you see up here in terms of doing a sample is it identifies the organisms sample, that's the total numbers is usually collected when they're doing a site assessment. Taxa richness, that's the number of different types of things that are collected. So when we recently did a spot in the past, we had seen 10 different species. When we went back this time, we saw 17 different species, or 17 different taxa. We don't identify things to species. Generally, we identify things to order and family. Family is most typical. On the far side over here, you'll notice that each taxa has got a weight in that column, the taxa index in that yellow column, and that is the weight, the water quality weight that it has been given as part of Riverwatch. In the upgraded version of the world, you see the rapid bioassessment book that's over on the side. There are 1,000 different species that are identified in that and they're all given weights of one form or another relative to their response to different types of, mainly to organic pollution. In the book, in terms of the way the book is organized, what you see in the top is the common name. It's given that taxa weight, remember what we're looking at with that, and the taxa hierarchy is just what order, family, genera does it belong to. On the left-hand side, you see anatomical traits used for identification. So what you see up there is an amphipod, and what you see in terms of in the book and the taxa description, you'll have the things that are used for purposes of IDing that particular macroinvertebrate. We identify ecological significance in that section, and then you have the relative size range. One of the things that surprises people is how small some of these things are. When we did the book, I could put a scale on, like that little red scale that you see, but that little scale that you see is still difficult to interpret. So what we did is we tried to compare everything to the size of a penny. So in the book, you may see pictures of it, but if it's smaller than a penny, you'll see the penny will look very large. On the other side of the page for it, what we will identify is fun stuff and an elaboration of details of the ecology and character of the taxa that you see. What you see there is a leech, and what is common to the leech, it's got a rasping mouth parts, and it has a specialized Hirudinen thing that can be used to, it's an anticoagulant that is used by leeches for it. Leeches are still used in medicine. So when people have a really serious bad hematoma, the leeches are used for bloodletting for it. They reproduce, they are hermaphroditic, they reproduce, and what you see in terms of the picture up there isn't one leech, but the one that's up on top is 1, 2, 3, 4, 5 different leeches that are there in a brood sac for it. So there's things concerning the character of the individual organism that are in the book, and there are adaptations to flow. What you see in the top right, black fly, and it's got little hooks that go around the one part of it that is an attachment for it. It's clingy and stationary. If you have been to Minnesota and to the boundary waters, you are very familiar with black flies. They are very common, and we'll talk a little bit more about them. Down below that, you see a free swimming mayfly that is, it's like a torpedo shape, so it's got things that adapt it for faster water. You have a riffles beetle, and it's got small little hooks on the bottom of its pants. On the one that is down below, you see the heptogeny is flattened, and so the waters go over it. Engineers actually identify something called a Reynolds number and have done things to take organisms that are still this small and try and evaluate the character of how they perform under different sorts of flow regimes. And there are different feeding groups in macroinvertebrates. So the organisms you see up on top is something called a torpedo mayfly, and it has a brush-like mouth parts and a brush-like limb, and it uses those to filter feed. You have, right to the right of it, you have a piercing harpoon on the fly for it. You have the leeches that generally are bloodsuckers, but there's more than one type of lifestyle that they indulge in. Down below that, you have a dragonfly nymph, and with that large mouth part with that, that's something that's called a labium that it uses to trap prey with. Down below that, you have something that scrapes rocks. So all of these are different types of adaptations for living in water. Collectors and filter feeders, parasites, predators, scrapers, and shredders. Okay. The first group that is up there is an amphipod. And if you are a fisherman, you should give them a big thank you. They wind up being one of the most common elements in stream systems. The one you see in the middle is not from a stream. That's from 1,000 feet deep in the ocean, collected by James Cameron. So what you see is there are actually well over 1,000 different species of different forms of amphipods that exist, and they are very common in stream systems around our area. The one that you see on the far right is something that's called a sow bug, and I'm told that they're called roly-polies. I've not experienced roly-polies before in the terrestrial, but that's what I understand. And they're called isopods because the lake size is all the same. Amphipod, the leg size is different. Isopod, the leg size is different. Taxa weight. Isopods are indicative of high organic loading. So the weighting for the isopods is higher than it is for the amphipods. Amphipods indicate higher water quality, isopods lower water quality, based on that ranking. And amphipods are also used as a basic bioassay organism. So when you're taking a look at the impact of different types of toxicants, these are used as bioassay organisms for that. The importance of isopods. Diporia is an isopod that existed in Lake Michigan. What you see is a transition up the series of Lake Michigan maps that you see on the far left top is what it used to be. What you're seeing is the disappearance of Diporia, most likely as a consequence of zebra mussels and quagga mussels. And the Diporia were an important food source, and notice that they're high in oil content. Hard to think of the smallest things as being important for different types of food elements, but they're extremely important for in the food web, and they're important for alewives, whitefish, and sculpins. As a consequence of the disappearance of that, there are impacts higher up the food chain. That's my boat. That's my John boat. What you see in the bottom, now that's an inland lake. What you see on the boat are zebra mussels. And what you see on the fat mucket that's up there is zebra mussels. All of these were from the lake that I live on, Third Lake. A lot of it has disappeared, so the population numbers can move up and down on it. So what you see on the far right is what it looked like, maybe 5 to 10 years ago. What you're seeing currently is the size of the adult zebra mussels has shifted, and they're only maybe about a half-inch in size, where they used to be a couple of centimeters. That reflects changes in the character of what's going on in the lake. In assessing high-quality stream environments, there's multiple ways of doing that. And one of the most common ways, and what the folks that are macroinvertebrate specialists use, is something called an EPT index. And what that is simply is what are the number of mayflies, stoneflies, and caddisflies. So the EPT taxa index, by identifying those numbers in your collection, that's used to grade out the character of the overall. Below that, you see the MBI metric. That's a different metric that's also used in the Riverwatch material. So it's the sum of the taxa numbers. You've got the taxa weighting, remember the grading out of it. And when you take a look at how the numbers add up, lower numbers are better than having higher numbers. So a leech and certain sorts of worms would be given high numbers. Things that like stoneflies would be given lower numbers. And for the mayflies, one of the things that you see up there is an identification of the anatomical sorts of things as a descriptor for the mayfly. So head, first part of it, thorax, and that's where the legs are normally attached, abdomen, and then 3 caudal filaments. Those are elements, especially the 3 caudal filaments, that can be used to identify some of the mayflies. Now, this is a torpedo mayfly. They are streamlined. We had mentioned that before. There are swimming mayflies. These are different varieties of mayflies. When you do your river watch things, what they are asking you to do is to differentiate between the different types of mayflies. So in that list of 40 different items, there's 4 or 5 different types of mayflies they ask you to identify. When you do your work this afternoon, you'll look to see if you can identify the differences that distinguish the mayflies. So you see up to the left, the Heptagenia, there's dorsal ventral flattening. You see down below the character of how it is flattened top to bottom. On the one that's on the right, you'll notice 2 little things that are up here. Those are hardened shell components, and underneath it you have different, they're not lungs properly, but they are looking for a word, I'm missing it. Bottom line is the fact that you've got those 2 hardened shell things, that's what is used to be able to identify the animal. And you will be very surprised. You see the penny beside it. They are exceptionally smaller, and you will have some crawling mayflies as we've passed them out in the collection. And this is Heptagenia, and it is, you find it in our area. So out in the south side in Spring Creek, we find them, and they are burrowers. So those tusks that you see are used for burrowing, and this can be a very common mayfly. And as you see here, what you see in the upper left, that's a radar signature of a hatch of Heptagenia burrowing mayflies from up in Wisconsin. All of that is mayflies. What you see is a handful of mayflies, and what you see to the bottom, now this will be for the adults that have hatched, and what you see at the bottom is a gas station where the mayflies have clearly accumulated. One of the genera that is indicative of good water quality, you don't find them in bad water quality, you find them where things are good, are what's called stoneflies. And you notice that it has 2 anal cerci from it, bifurcated claws. Those are things that are used to identify it. That's what distinguishes it from looking like a mayfly. Do some of these things look alike? Absolutely. And that can make it difficult to distinguish. Caddisflies are unique. One of the things you'll see, this organism has got 1, 2, 3 different plates that cover its thorax that's used for purposes of doing its identification. Caddisflies make cases They pull all sorts of things around them. Some caddisflies have cases and stones and wood types of things. Some caddisflies spin nets and use the nets to be able to feed. And you see pictures of it. Caddis is from an English term. It comes from clothing salesmen that used to put samples of the things on them themselves for purposes of selling different sorts of cloth material. So it comes from kind of an old English term. And you see adults that will be different than the look of the larval forms. And there's some versions of caddisflies. The one that is down below that looks like a snail, people originally thought it was a snail. That got cleared up. Do they occur in our area? Answer is yes. You do occasionally see it. It's not common, though. And then there's a giant case builder. Again, take a look at the penny comparison for the things. And then you have aquatic beetles. For purposes of river watch, you don't have lots of different beetles. The beetle that it's essentially just two beetles that they look to pick out. One is a whirligig. I'll bet you've seen those in ponds and in stream systems. And the other is the riffles beetle that you see up at the middle and top. Riffles beetles are very, very tiny. And the last one that you see down there at the bottom, this is the penny. This is the water penny. Very, very tiny. Again, size is deceptive on some of these things. These are some other types of things. They're not, Riverwatch doesn't ask you to identify these. These are larval forms of other types of beetles that you see. So you have predaceous diving beetles. You see them with the large mandibles and mouth parts that are used for clinging to prey. And dragonflies, there are a number of families of dragonflies that are in our area. They have incomplete metamorphosis. What does that mean? For invertebrates that go through a pupa stage, that's complete metamorphosis. If you have larvae that change size but do not look any different going from the top to the bottom in terms of size range, that's incomplete metamorphosis, and dragonflies undergo incomplete. Yeah, and they are predators that engulf their prey. And what you see down at the bottom, if you look carefully, is a dragonfly that's busy catching a minnow. And if you take a look at the gentleman with the interesting model from Aliens, there's been at least one thing that indicated that the extensible jaws that they included in Alien came from somebody that had been taking a look at dragonflies for it. And there's dragonflies. These are damselfly larvae. The Riverwatch program asks you to distinguish between different types of dragonflies. What you see up here, if you notice the antenna is thick and the first element of it is long, when you go down to the one that's here, you notice that the antenna is not like that. They show also the the fan type of thing from the back, and that is different between the different types of damselflies. The one here is shortened in the center. The one for others is the same size of it, and this one obviously is just 2. So those are ways of distinguishing the damselflies. And the good, the bad, and the ugly. Okay, snipe flies are found in relatively good water quality. And this is what an adult snipe fly looks like. For a lot of the flies, you'd never guess what the adult looks like if you're taking a look at what the larval form is. So, and the taxa index, remember good, bad, and so good, the taxa index is only 4, which means, again, you find this in good, associated with good water quality. Black flies, by contrast, are Minnesota's monster. If you have ever been up to Minnesota, you almost certainly will have been bitten by a black fly. Now, in Africa, black flies are a serious problem. They are carriers of river blindness disease. They don't do that here in this country, and generally they can be associated with some fairly good water quality. So if you're looking at a riffle, it's not uncommon. And remember what the attachment was on that? Remember the little hooks that are at the bottom of that bulb from the black fly? Here's the bottom of it. That's where the hooks would be, and it's got a fan that's up at the top. So they do bite and look for blood and tough. These are midges, and there is what they call a biting midge, then there's a non-biting midge, and then there's a bloodworm midge. They are all different. They're not the same. They have different anatomical things that distinguish them. What you will see down here, you notice the little tubules that are here. The color is associated with having a type of hemoglobin type material, and they are found in places that can be associated with sewage waste. So these are an example of macroinvertebrate that's kind of an index of poor water quality. And what you see here is, remember that there's more than one type of, more than one type of taxa. So there's snails, there's worms, there's crustaceans. These are worms that is the archetypical signature for sewage treatment plants. These are tubifex worms. What's the difference between the worms that you find in the water and the worms that you find on shore? They are segmented. It's similar to earthworms. They have hair on each segment. They texture bottom sediments. They burrow into the upper layer and keep it oxygenated. So the worms, again, what you see up there is not a nail, that's a pin. So again, looking at these things, they're exceptionally small. Well, again, these three macroinvertebrates tend to be associated with relatively good water quality. And they are larger than the other things that you see. So if you look at the alderfly, it's almost the size of a penny. And you have substantial differences, even though they are related taxonomically. there's substantial differences in there's a single spiracle from the alderfly, there's hooks on the fish fly, and there are similar sorts of things on the hellgrammite. So the difference between Riverwatch and IEPA, 1,600 taxa for that. They have different collection methods, and they have different ways of grading the water quality. So they look for the number of beetle taxa, the number of mayfly, the total number of taxa. So there are different ways of doing and grading macroinvertebrate collections. 2 warnings. Watch out for giant alder flies. And sleep tight, don't let the black flies bite. So that's pretty much, do you have questions? And you'll forgive me, one of the things that I'm 81 going on 82, I'm experiencing some verbal problems. So I apologize for it, but hope we've gotten through some of it anyway. And that is what you find in the book. What we can do, what I'd like you to do, is come on up and take a look at the things that are here. And if you have any questions, oh, I know it, I almost forgot something. The hard copy that you see of this costs something like $75 to make a copy of. If you sign up, I'd be happy to send you a computer copy of it. So we can send you a computer copy of that. I should. And in terms of the Riverwatch program, we should make certain that I haven't forgotten to identify the place where you can get hold of that. One of the things that has happened recently, there is a very special thing that has happened. There's something called Macroinvertebrates, Inc., ING. And it is a program that was put together by the National Science Foundation. And it also goes through identification types of protocols and is wonderful. It's absolutely wonderful. And you can access it by going to macroinvertebrates.inc. And it will have a copy of computer-based identification manual. And it also is very good. Come on up and take a look at the books.
Excuse me, what was it was, sorry, macro.inc, I-N-K, or was it
Macroinvertebrates.inc.
I-N-K?
I-N-C.
Okay.
Yeah, you have an annotated list of these books with some comments on them. The book that you're looking at right now is talking about an introduction to macroinvertebrates. Baloney. This is a large-scale, very, very difficult book, but it winds up covering the entirety of the sorts of taxa that you're going to see, aquatic insect taxa especially. What has happened is that through time, the character of doing these guides that Hilsenhoff was the originator of, now we have volumes of information and and the programs are emulated by lots of other people. So this is a book that US EPA will put out, and what you see in the back part of it, remember there's taxa weighting, 1,000
Cool idea.
different taxa. So somebody like IEPA that has to do 1,600 will use something like this or their own set.
Sounds like a tax at work.
Yeah, this is a wonderful book. If you're doing identifications, this is one of the easier things to use and is valuable and worthwhile.